Hello everyone, welcome to Gangs of PCM. This is Priyanshu, and together we are going to solve all your physics related queries. Okay, so once again we have come with a video in which we are going to solve previous year JEE Mains question. This time we are going to solve the question which came into January of 2020, examination JEE Mains examination which was held on January of 2020. Okay, now this question is from chapter capacitors. What are capacitors? Capacitors are the devices which are used to hold charge or electric energy. So if I want to hold electrical energy, then these capacitors would be the perfect device to do that. Okay, so these are the capacitors. And what does the question says? A question says that a parallel plate capacitor has a plate area A separated by distance d between them. So we have a capacitor. Let's draw this. So we have a capacitor. This is our capacitor. The area of the capacitors, area of the plates of the capacitor is A, and the distance between the plates is D. So this is the area and this is the capacitor. This is the area and this is the distance between the plates. Okay. Now the second thing it says is it is filled with a dielectric of dielectric constant that varies as Kx is equals to this. Kx is equals to K times 1 plus alpha x. Now we don't need to worry about this part. Let's just understand how the dielectric behaves. So it happens, so we are saying that we are filling the dielectric or we are filling the capacitor with a dielectric. Okay, this is filled with the dielectric at any position. If you want to find the dielectric constant, then dielectric constant is given by Kx. So let's not worry about this for now. Let's see what happens or how we can solve the questions which involve dielectric inside a capacitor. So let us assume this is our capacitor and we are filling it with three different dielectrics. So we have one dielectric over here, other dielectric over here, and other dielectric over here. So three different dielectrics we have, let's say K1, K2, and K3. So how do we solve this? Okay, so the each capacitor or each part of the capacitor with different dielectric can be treated as a different capacitor. So over here we'll get how many capacitors? We'll get three capacitors. And these capacitors, since they are connected side by side, can be treated as capacitors connected in series. So the capacitor with K1 dielectric, we'll say the capacitance of this is C1. With K2 dielectric, we'll say it is C2, and then K3 dielectric, we'll say it is C3. Now since these three are in series, the equivalent capacitance of this combination would be given as 1 by C1 plus 1 by C2 plus 1 by C3. And this is how we can calculate the equivalent capacitance of this capacitor whose the area between the plates is filled with different dielectric. Why did I show this over here? Because there is the same thing which is happening over here. Since the dielectric is changing, the value of the dielectric is changing with this relationship. Kx is equals to K times 1 plus alpha x. This is the relationship with which your dielectric is changing, or the amount of dielectric or the dielectric constant is varying throughout the capacitor, or the thickness of the capacitor. Now what we can say? We can say that your capacitor can be assumed to be made up of infinite small capacitors, infinite small capacitors, okay, infinite small capacitors, each of thickness dx, each of thickness dx. Now dx is approaching 0, that is almost very small. This is almost not, or it is approaching 0, it's infinitely small. That means what? That means we can assume we we can assume that for a given x, for a given dx segment of dielectric, given segment of dielectric, dielectric constant or K is constant. So dx is so small, the dx value is so small that for this value, for this segment, we can assume our dielectric to be constant or dielectric constant to be constant. Okay, so that's over here. If we have understood this, then we can go on with the question. Now, what would be the capacitance of this small part? Capacitance of this small part would be what? DC. Let's say the capacitance is very small, DC. DC would be equal to what? DC would be equals to K, whatever is the dielectric constant over here, times epsilon naught A by D. See, area of all of these strips would be same. Area of all these strips would be same as A. So it would be epsilon naught A by D. Now D is the thickness. So over here D is dx. So epsilon naught A by dx. This would give you the capacitance of this small segment. Now if I want to find equivalent capacitance, okay, 1 upon C equivalent. As you can see, these infinite capacitors are in series. Okay, so that means what I can say, the equivalent would be 1 plus 1 by dc plus 1 by dc plus 1 by dc plus till till infinity. This is how we can represent. Okay, each of them would have the capacitance equals to dc. And how many capacitors we have? We have infinite capacitors. Okay, so we are arranging them like this, or the equivalent capacitance can be given like this. Now how we can solve this? Obviously infinite addition would be a little bit difficult, and we know that we can do infinite terms of addition, or we can do infinite areas of addition by using your, so if you want to do infinite additions, for that we can use integration. So it would be 1 by dc. Okay, this is then how we can represent this. This would come out to be dx upon k epsilon naught a. Now what we can do, now see, the variable over here is what? Dx. This is the variable. So our limits of the integration would be applied for this value of x, which would go from 0 to d. See, over here the value of x is 0, and over here the value of x is d. Okay, so your value of x would go from 0 to d, and we'll integrate this. Now this is not complete. What is k? Now k is kx. So if we replace it over here, what you'll get? You'll get k1 plus alpha x into epsilon naught a. Now this k is constant. Over here, this k can be written as kx. Now kx epsilon naught. Okay. Now what we can do? Now, how we can say what is happening over here? So you can say C equivalent. This can be written as 1 upon k epsilon naught a. These are constant, so they can come out of the integration. You will have 0 to d dx divided by 1 plus alpha x. Now see, since it is given in the question that alpha x is much smaller than 1, then we can represent this in such a way that it can be written as 1 plus alpha x to the power minus 1 dx. Now since we know that by binomial expansion, if 1 plus x to the power n can be written as 1 plus nx if your x is less than or very extremely small. If your x is extremely small, the condition is satisfied over here. Alpha x is very small. Alpha x is very small. So now what we can say? We can say 1 upon c equivalent is equals to 1 upon k epsilon naught a. 0 to d will apply the binomial approximation, which would be 1 minus alpha x dx. Okay, now let's integrate this. What I'll get? 1 plus k epsilon naught a. Integration of 1 would give you x. So you'll integrate it from 0 to d. Minus alpha would be constant, and you will integrate x. The integration of x dx is x squared by 2. 0 to d. You'll put in the limits. If you put the limits, what will be the answer? You'll get 1 upon k epsilon naught a into x, d minus alpha d square by 2. So this is 1 by c equivalent. Is the Have we reached the answer? No, we have not reached the answer because this is 1 by C equivalent and the question asks for equivalent value of the capacitance. So what is the equivalent value of the capacitance? We will do the reciprocal for this. So what we'll get? The reciprocal will be C equivalent is equals to K epsilon naught A. Okay, K epsilon naught A. What you can do is you can take D common from here. So you'll have divided by D 1 minus alpha D by 2, which can be further written as K epsilon naught A by D 1 minus alpha D by 2 to the power minus 1. Okay, now what we can say from here? See, this alpha D by 2, this is again what? A very very small number. Alpha D by 2 is much smaller than 1. It's a extremely small number as compared to 1. Then we can again apply binomial approximation for this value. So what will be the answer? Answer would be C equivalent is equals to K epsilon naught A by D 1 plus alpha D by 2. What we are doing over here? We are applying binomial approximation, which is equals to what? Which says that 1 plus x to the power n is approximately equal to 1 plus nx if x is very small. If x is very small. So with this, we get the answer. Your answer would be C equivalent is equals to epsilon naught A by D in the bracket 1 plus alpha D by 2. If you look at the options, we see that your option B is the right answer. Your option B is the right answer. So correct answer would be B. Okay. So I hope you have learned something from this video. If you have liked the video, please like it on the YouTube. And if you're new to the channel, please subscribe. I hope we meet again. With this, I'm signing off. Thank you.